Hi, Elizabeth here, production assistant for the PodRocket podcast. Before we dive in, did you know that PodRocket is on YouTube? You can catch the full video versions of our episodes over on the LogRocket YouTube channel. Click the link in the description to tune in and subscribe so you never miss an episode.
We kind of went back to the drawing board and really thought about what a database should look like if it was built on today's latest developments in cloud computing infrastructure. And we came up with this architecture based on unikernels and also some bits and pieces of Cloudflare in there as well that are the foundation for Prisma Postgres.
Hi there, and welcome to PodRocket, a web development podcast brought to you by LogRocket. LogRocket provides AI-first session replay and analytics, which help you surface UX and technical issues impacting your user experiences. Start understanding where your users are struggling, and go try it for free at logrocket.com today. My name is Paul, and joined with me is Nikolas Burk. He is a developer advocate over at Prisma. We're going to talk about something new and exciting today, a new taste on the tongue, Prisma Postgres. Welcome to the podcast, Nikolas.
Hey, Paul, thank you so much. I'm excited to be on the show today.
So you've been at Prisma this whole time. You haven't shifted around.
I've actually been at Prisma for over 8 years now. So I've been the third employee in the company, and I've seen all the changes, all the evolutions, and I'm still here today.
That's amazing. 8 years is like a trophy. You should get a trophy or something, no matter what tech job you work if it's 8 years.
It is pretty unique in our industry, I think. So yeah, the main thing I think why I'm still here really is that even after 8 years, it still feels like we're just getting started, literally. This is just like the launch of Prisma Postgres that we just had. It was like one huge milestone in the history of the company, probably the biggest one that we've had so far, along with the release of the Prisma ORM, I think 3 or 4 years ago. So like this feeling of still doing so much for the developer community and just getting started has kept me here.
What was the most potent phase of self-growth, you think, in your 8 years at Prisma? Was it pre-ORM, post-ORM, now?
It probably was the first years, like the first 1-2 years when we were just like 5 people, the 2 founders, 3 employees, like working around the clock the entire week. That was super intense, but also like very rewarding. And I think it set the groundwork for where we are today. So I think that was probably the most impactful time in terms of growth. And then for me personally, there were a couple of more stages where at a time I became a manager, was leading the developer advocacy team myself, then stepped back to just being an individual contributor again, because that's the kind of work that I actually enjoyed. Like I wanted to be the person that was talking to developers, writing content, teaching how to use the Prisma tools ultimately.
I'm glad it's been a self-fulfilling experience. Evidently, it's been great for you, Nikolas, because it's 8 years. And now there's even more groundbreaking stuff coming up by Prisma. Prisma changed the game for a lot of developers when that ORM came out. It really did. And it's stuck around. It's not in any way decreasing in popularity. And now there's a way to wrangle that last bit of what a developer might find difficult to understand or difficult to tool with if you're not like coming from the infrastructure, SRE, backend area. So jumping right into it, what is Prisma Postgres? Is this a SaaS? Is it a type of database I can use? What's going on?
Prisma Postgres is a serverless database that you can use to build your applications. And it's really unique in the way how it's built, actually, because I think that a lot of people say, okay, what's so exciting about another Postgres database? Don't we have enough of these already? But actually, if you look at the architecture of most of these and how these are built, they follow either of 2 approaches. It's either that they're just built on top of AWS or some other major cloud provider, essentially becoming a reseller of that infrastructure, right? Or they go and set out to build their own database system based on containers. They have to orchestrate the entire infrastructure, which gets really complicated and really complex. And especially with the first approach, where you're reselling infrastructure of a major cloud provider, you're bound to all the technical constraints and pricing models of that cloud provider. And it's really hard to build a sustainable business on top of that. So what we did with Prisma Postgres is we went back to the drawing board and really thought about what a database should look like if it was built on today's latest developments in cloud computing infrastructure. And we came up with this architecture based on unikernels and also some bits and pieces of Cloudflare in there as well, actually, that are the foundation for Prisma Postgres and all the great benefits that it offers to developers.
That's so cool. So there's a lot of other companies I've noticed starting to sprout like a new type of plant in our industry that are going back to the basics, like you said, back to the drawing board. I'm not sure if you're familiar with fly.io. Like they've been spinning up their own infrastructure and it's like cheaper, it's smaller, it doesn't have the white glove experience per se that AWS does, but it's speaking to a severe need in the developer ecosystem as the broad base of those people grow. So when you say unikernel, you guys have essentially made a single purpose, like or some distribution of some OS that is specific just for hosting Postgres. Is that the first sort of innovation layer?
Yes. So that's indeed like one of the core innovations that we're building on top of unikernels and bare metal servers, really. So we're deploying our own Postgres databases on our own bare metal like servers. Like one big benefit of that approach actually is that Prisma Postgres, unlike other serverless databases, doesn't have any cold starts. And like when I speak of unikernels, you can imagine it as a kind of hyper specialized operating system that only has the resources that it actually needs to run an application. So if you think about a traditional operating system like a Linux distribution, it has all of these things that an application might not end up needing, like the user shell, certain drivers, and like libraries, the file system, like things like that an application might not end up needing, but that are still there, that adds weight to the entire like deployment image in the end, and also in the end competes for resources with your own application. So that's where the unikernels really stand out in terms of efficiency.
It's almost like it's the concept of a Docker image. It's only build what you need, but Docker still ships with the whole Linux. It still has that whole thing. You guys made your own like hyper specialized, call it an operating system. It's made just to run Postgres. And one of the benefits I know from my pre-reading here is it eliminates cold starts. So is this just because of the lightweight nature of the unikernel and the basis in which it runs? How does that work?
Yes. So I want to like first come back to this idea of a unikernel and maybe give people an even better understanding of what it is, and then talk about the entire tech stack that's involved there that enables this no cold start property of Prisma Postgres. So I think one way, if we think about a real world analogy, then one way about thinking of unikernels versus traditional operating systems is also in terms of a Swiss Army knife, that's the traditional operating system, and then a scalpel that's really just sharp and is there to do exactly one thing. And if you're a surgeon, then you can't really get very far with a Swiss Army knife. Like it has a lot of stuff that you don't actually need, that you still have to carry around with you every day, but that you're not going to need. And also it's not as sharp as the scalpel. So that's the traditional operating system. And then a unikernel, on the other hand, that's the scalpel. It's there for exactly one purpose. It's super efficient, very lightweight, and really good at what it does. And unikernels have been around for a while. Like they're not a very new technology, but only in the last couple of years, they're now at the point where they're ready for mass adoption. And in fact, we have been monitoring this space for a while, and one company has been really standing out in terms of how they pioneered the unikernel ecosystem. And that company is called Unicraft. And we reached out to them and actually started a collaboration to work on Prisma Postgres together with them. They were actually a huge helper in getting this thing off the ground. In the end, we had this like synergy of like database experts on the Prisma side on the one hand, and then the unikernel experts on the other side at Unicraft, and then merging that to build Prisma Postgres and really ensure that this thing becomes the most efficient database that's like out there on the market today. So we're using Unicraft's unikernels, and that's one big component just because we have this hyper specialized operating system that we don't have any cold starts. But there is more to that and more to the Unicraft stack in general. And this Unicraft stack, by the way, is also available for just application developers that are building applications and are looking for better ways to deploy their apps than traditional like serverless functions. And so if we look back at the Unicraft stack, there are several components to it. One, and the first component is a custom networking layer that is using a custom controller and a custom proxy. So that's the part where incoming TCP connections, in the case of Prisma Postgres, are being like managed and handled. And from that networking layer, the data and the request flows through what's called the cloud stack. And that consists of a virtual machine monitor, also called hypervisor. That's the layer directly on top of the hardware that's provisioning resources to the VMs, in our case, the unikernels. And then there is one additional bit to that entire stack, and that's a snapshotting mechanism. And that's also really important because with these two layers, the networking layer and the cloud stack that I just talked about, you already gain a lot of performance. But if your application in it by itself still takes a lot of time to load up, to initialize, like a Postgres database typically does when it needs to load its configuration, maybe replay the write-ahead log, initialize all the processes, that still takes a lot of time. So the way how Prisma Postgres works in that regard is that we're taking like memory snapshots of each database instance that we store in memory and can wake up again in just a couple of milliseconds, like single-digit milliseconds. And that's why we don't have like cold starts as the only serverless database out there, because all other database providers, they're running their like database instances in traditional containers that just have a much longer startup time, and you just can't beat the unikernel and unicraft approach here.
That's really neat. So I guess RAM's cheap nowadays, or cheaper. So it's a lot easier to do shenanigans like this. So when you say a snapshot, what is inside of the snapshot? How do you maintain the correct state of the snapshot? And how do you make sure you target the correct state when you boot it back up?
I can speak to like how the correct state is being targeted, because that's also part of this Unicraft layer, the custom controller that's having an overview of all the database instances that are running on a given machine. And in terms of the state, I guess it's just the entire state of the database, including the data, including like even the TCP connections, like warm TCP connections can be part of the snapshot and are being warmed up in a couple of single-digit milliseconds for the database to react. So yeah, that's how it works under the hood. A little bit of a disclaimer there. I haven't worked on this myself. I'm not one of the engineers who has built this, but over the past couple of months, I've been very involved with that work that our engineering team has been doing, and also have talked a lot to the Unicraft team, and was like a fly on the wall when it came to figuring out the architecture and all these details. So yeah, that was my role in the entire thing.
So I guess that kind of does answer my question. It takes the whole state, which is, I was like, that's too much. They must do some indexing along the way or something, but no, you take the whole state. Is there any like fear of future-proofing this sort of architecture when it comes to large database sizes and the requirements of large provisional sections of RAM that you might need to reach for when doing this? Or is the RAM to do the snapshotting sort of fluid, so you can balance where the memory is required during these reboots and stuff?
So because we have the entire control over that hardware layer by running all of this on our own bare metal servers, I think we're not too worried about these kinds of issues. Of course, especially in the beginning, we're closely monitoring the usage of Prisma Postgres, trying to understand the usage patterns, the scaling patterns that applications have, so that we can actually make sure that we're never running into situations where we're running out of memory or anything like this. But in general, I don't think that this is too much of a concern, mostly because we are entirely in control over that entire layer, and we can pretty much do whatever we want with it. It's going to be just this constant mode of observing, monitoring, learning, and adapting that we'll go through in the next couple of months and years with Prisma Postgres.
Do you see Prisma Postgres becoming, as long as this continues to go well, the default thing folks start to reach for when it comes to a modern tech stack. These days, a lot of folks say, oh, you want to deploy in Vercel, go use Vercel Postgres. You're doing it on your own container, go use Fly Postgres. But you always have to plug Prisma in somehow, granted you're using this, into whatever underlying technology. Here, it feels like a hand in glove. Do you guys see a future of developers just automatically reaching for some out-of-the-box configurations that you folks will provide with the service?
That is definitely our goal, right? We want to make Prisma Postgres as successful as possible. And we think that we've built something that's substantially better than what's out there on the market today. Plus, we're also actually working with a lot of cloud providers to bring Prisma Postgres closer to their users. So as an example, we've worked already with the Netlify team and have built a Netlify extension so that any Netlify user can now connect to a Prisma Postgres instance directly from the Netlify dashboard, essentially. So they don't even need to leave Netlify in order to use Prisma Postgres in their site. We're going to do the same with Vercel Marketplace so that people can also, if they're already deploying to Vercel, have a really easy time integrating Prisma Postgres into their apps on Vercel as well. And yeah, I guess that's part of the strategy, to go where developers are already and make it as easy as possible for them to integrate Prisma Postgres into these apps that they're building already.
I love hearing about easy integration because, like people alluded to at the beginning of the show here, serverless, non-serverless, pooling, non-pooling, SSL, like a lot of people don't want to think about this. And so any options that allow you to just get up and running, even if it's not my set in stone configuration, it gets me moving quickly, which is so important for ideas. So if I envision myself using Prisma Postgres in the near future, I want to know, okay, we talked to Nikolas, we talked about some of the infrastructure and these cool things. How does this beat state of the art for me? Cold starts are cool. Anybody who's on the back end and infra side is going to think the cold start thing is cool. What else is there? So I know caching, query optimization. How does caching work? You guys are a database layer. How are you caching my database?
That's a really good question. We've now talked about all this cool architecture stuff, which is a little bit nerdy, but the typical developer, they won't care about it unless it gives them some tangible benefits, right? So we actually think that also on that level, like Prisma Postgres can really compete with everything else that's out there. In the first place, Prisma Postgres is a serverless database and comes with all of the benefits that just a serverless database has in the first place, where you don't need to manage your own infrastructure for the database in the first place. It has on-demand scaling, can keep up with like traffic spikes to your application. It has pay-per-use pricing, which I think is very good to make your bill at the end of the month predictable and understand like how that happened. And at the same time also serves for situations where you maybe have traffic spikes, where in a traditional model you would have under-provisioned your resources, or at the same time ensures that you don't pay too much when you're using your database because you've over-provisioned any resources. So it has all of these benefits, but then it has the no cold start benefit on top of that, which I think in it by itself is pretty huge already. Then you mentioned the caching layer. And that's actually something that we're really excited about. That's actually, it sits on top of Prisma Postgres, on top of the unikernel layer, and is built in Cloudflare infrastructure using Cloudflare workers and the Cloudflare caching API. And that means if you're familiar with Cloudflare, you know that they have data centers across the globe. And that means that if you're caching your data, exactly, you're caching your data super close to your users, and you don't have to do anything for that when you're using Prisma Postgres in terms of setup or configuration. Imagine what a huge step forward this is compared to a traditional cache setup with Redis, where you actually need to run and operate an entire Redis server, implement your own caching strategies, make sure that the cache doesn't get stale and all of that. With Prisma Postgres, this cache is built into Cloudflare workers, very close to where your app is running. And you can configure your cache strategies for every query. That means if you have a very complex query, you can say that it should be for a longer time. A more important query where you really don't want to have stale data, you put a cache that ensures that it's always fresh. So things like this make just a really outstanding product in it by itself, actually. And it comes out of the box with Prisma Postgres.
I mean, being able to tap into Cloudflare or Akamai or any of these fundamental level CDN networks is just, you can't beat it. That is the gold standard. And the fact that you can do it on a per query basis, I think that was my question. What do I get to control? And if I can do it for every sort of business logic, pedantically, that's ultimate control. You don't need anything more than that, really. What's the management looking like for that? Can you do a YAML or JSON configuration to set up your cache control? Is it in the code? How does that work?
It is in the code. It's literally in the database query that you're passing or that you're formulating in your TypeScript code. You're passing a stale while revalidate SWR and time to live TTL option that determines how long this particular query result should be cached. Yeah. So that's how easy the config is. It's right there in your application code. You don't have any further config that you need to take care of here.
Similar questions for the caching.
Yeah, we have a tool that's built into Prisma Postgres as well that's called Prisma Optimize. And that is actually a tool that analyzes your database queries, and it gives you hints and insights into improving their performances. So when you're missing an index, which is like the most common situation for a slow query, that's also a common situation for on traditional providers increasing your bill because a slow query costs compute that you're paying for with actual money. So we are actually taking care of that with Prisma Optimize by giving you recommendations and catching these common mistakes that developers do when they're like running queries. In the same way, like we have recommendations for overfetching, using proper data types. So we'll catch all of these little things that a developer may not be aware of if they're having a slow queries and giving them practical recommendations for optimizing them. But we also have another really cool feature of Prisma Postgres that I think is a little bit underappreciated. And that's a real-time event system that's coming with Prisma Postgres, meaning you can subscribe to changes that are happening in your database and have these changes be delivered into your application code in real time using WebSockets.
So here, this is a whole other option. You don't need to necessarily use a backend as a service.
Exactly. And the way this is built is actually also really interesting because a lot of real-time systems suffer from issues about reliability, robustness. They may send events multiple times just to be sure that it arrives if a server went down along the way. It's very hard to build such a real-time event system that has the right delivery semantics that subscribers can be sure that they're actually receiving an event at least once and also receive them in the right order as they were produced. And the mechanism that Prisma Postgres is using for that is called change data capture, that relies on the idea of unidirectional data flow, where some changes made to the database, that change can happen from anywhere, whether you're writing into a table manually or whether it comes from an application. That triggers an update that sends the event into our event queue, which, by the way, is also built on Cloudflare. So again, Cloudflare infrastructure powering all of this. And from there, it'll reach your application and the subscribers. So that's the real-time layer of Prisma Postgres that I think also is very unique in terms of features that we see in the database ecosystem.
That's extremely unique. I just didn't think we could do a push style WebSocket without a backend as a service. As a dev myself, every time I've reached for something like this, it's always like socket.io or using Supabase or something. So now I can just do it in my database. I know they have things like Postgres extensions that help you do this, but I've never reached for it myself because there's that other end of the stick. It's like managing the events, making sure they come in the right order. That's what I don't want to deal with because it's always a mess. And this is so cool. And the fact that it's on the Cloudflare level, again, it's the golden standard of reactivity if you want to talk about the end user experience. I can't wait to try it. This is really neat. I feel like you can make some cool real-time applications. I agree with you, Nikolas. I didn't even have this come up in my pre-reading when I was like just Googling around, but this has to be the coolest one. It just eliminates a whole layer, the BAS. We're not at time, but we're running close to time. So I would love to ask a few higher level questions about like your experience at and now like working on Prisma Postgres. You're thinking like in the modern tech stack, you're thinking about how developers using Postgres today. You're looking at the ecosystem and what's out there. You've identified things that are missing with service providers. And that's like what you guys are offering with Prisma Postgres and all the features we were talking about today. On the actual implementation side, Do you feel like there are some things you just see devs continually do, whether it's with Prisma or without Prisma specifically, and you're just like, that's terrible. You shouldn't do that with databases. Or this is such an anti-pattern, and maybe it's not called out as an anti-pattern. You have this global seat being part of Prisma for so long. So I just have to add.
The number one bad practice, I think, that a lot of developers fall into is not ensuring that their database is running close to their application servers. I think that's a really big issue with a lot of applications when they see performance problems, because you have to remember that traditional databases, they use TCP connections, and establishing TCP connections takes quite a bit of time. And you have this three-way handshake and all the authentication stuff using SSL that's coming along the way. And that just takes a lot of time. And that multiplies when it's going over a huge physical distance. So I think that's one core thing to make sure that your database is running close to your application servers. Or in the case of Prisma Postgres, we'll have database replication at some point in the future. So replication can help with this. But this global cache that Prisma Postgres has also can serve tremendously with that, because then it doesn't matter where your application server is, because the data will be very close to wherever it is, right? That's, I think, one of the core things in terms of bad practices that we see around databases.
That's like exactly what I was looking for. Just like a cool thing you might have noticed like out in the wild that maybe people don't think of too often. And you know, the time for the TCP connection to be established, you can't ignore it. There are several like steps that need to happen, and just run a trace route yourself if you're curious. You can see that things take a little bit when you actually try to go across the continent or across the ocean, even worse. It's a physical difference. Very neat. If people wanted to try, turning back to Prisma Postgres, if people wanted to plug into it today and give it a shot, are they going to Prisma, the website, and signing up there? Are they signing up on Unicraft? Where are people going?
The easiest way to do it actually is you just open your terminal and you run the npx prisma init-db command. So npx prisma init with a db flag, db option, and that will take you through the setup process of Prisma Postgres, including authenticating you with the Prisma console, which is where you would do it otherwise. So otherwise, you could just go to console.prisma.io and get started there, set up your database there. But you can also just do it right there in your terminal. It'll walk you through the authentication, let you configure the region for your database, and you're ready to go and query after you ran this command. And we are like, once you ran this command, we also send you to a docs page that has like step-by-step instructions to then start querying the database from a TypeScript application. That's the best and the easiest way for getting started with Prisma Postgres today.
Awesome. And if people wanted to keep up to date with you, Nikolas, like you're a Prisma OG, do you blog anywhere? Do you have a website if people just wanted to plug in?
People can go and follow me on Twitter as @Nikolas Burk. And I think that's the main platform where I talk about Prisma and all the cool stuff that we're doing.
And for anybody listening, it's Nikolas with a K, Nikolas, and Burk with a U, Burk.
Also the K in the end, yes. Nikolas Burk with 2 Ks.
Awesome. Nikolas, it's been a pleasure having you on, and hella exciting to learn about Prisma Postgres. Look forward to trying it.
Thank you, Paul. It was great being here.